how to solve and work with compound inequalities today. And this is just an extension of what we've been doing. And I think you'll find that if you've been doing our other work, that this will just proceed from that. So we're going to be asked, like we've done on a lot of them, you're going to be asked to solve and graph the solution. Solve and graph the solution. So let's say that we have this problem. -2 is less than or equal to x minus 3, which is less than 4. And now you can see why it's called a compound inequality, because there are two inequality symbols. That doesn't make this any harder. It just means we might have to think a little bit more. So watch. I still add 3 just like before, but I don't add it just there. I add it to the 4 and to the -2. So we add it in all 3 places. Now let's see what we have. -2 plus 3 is 1, which is less than or equal to x, which is less than 7. And technically, we've solved it. But now we have to understand, what does this thing mean in terms of the solutions? Well, I told you to start at the variable and read from the variable to the number. So this is saying that the answers are the numbers less than 7 and greater than or equal to 1. So on a number line, here's 1, here's 7, 2, 3, 4, 5, 6. If I'm going to show this on a graph, it's less than 7, so it's an open circle, less than 7, but also greater than or equal to 1. And there's our answer on the graph. All of these numbers in between here, every one of those numbers is less than 7 and bigger than 1, right? So that one is done. Let's go on to the next one. This one's written a little bit differently. 6 is less than or equal to r plus 7, and r plus 7 is less than 10. Now notice this one's written with 2 separate little inequalities. They're not hard to solve. So let's go ahead and solve them. This one I subtract 7 from both sides. And now I'm left with -1 is less than or equal to r, but I told you we always want to read from the variable to the number. So it'd be better to say it this way. R is greater than or equal to -1. Read from the variable to the number. So this is part of my solution, but we have another one. Subtract 7, subtract 7. So r is less than 3. Now, look at our 2 statements here. See this word and? That's an important word. Is it possible to meet both of these conditions at the same time? It is. I can be less than 3 and bigger than -1. So this can work. Here's 3. Here's -1. There's 0, 1, and 2. So the numbers less than 3, open circle, shade to the left, and the numbers greater than or equal to -1 would be a colored in circle, shade to the right. It worked. All of these numbers in here meet both of these conditions. All of these numbers in here are less than 3 and bigger than -1. All right. Now let's look at one that has the word or in it instead of and. A plus 1 is less than 4, or A minus 1 is greater than or equal to 3. This one has the word or. Or has a different meaning than and. I think you know that. So let's solve this one. Subtract 1, subtract 1. A is less than 3. That's part of our solution. Let's solve the other one. Add 1. Add 1. A is greater than or equal to 4. Now let's think for a minute. This says that the numbers are less than 3 or bigger than 4. Those cannot both be true at the same time. That's why this word or is so important, because the numbers less than 3, here's 3, are this way. The numbers greater than or equal to 4 are this way. There's no way both can be true at the same time. That's why the word or is there. There's no way both of these can be true at the same time. So this graph is okay because I have the word or. If it would have said the word and it turned out this way, you'd really have no solution. All right. One last problem. This one also requires just a little bit of thinking. -2m plus 7 is less than or equal to 13, or (5m plus 12) is greater than 37. So we have two inequalities we need to solve. Let's go ahead and do our algebra and solve them. On this one, I subtract 7, and I have -2m is less than or equal to 6. Divide everything by -2. I divided by a negative, so I got to flip my inequality. Don't forget that. This is m is greater than or equal to -3. I'm not going to circle this one yet, because I want to see what's going on with the other one. Remember to flip your inequality. All right. Solve the other one. Subtract 12. 5m is greater than 25. Divide everything by 5. M is greater than 5. Now notice something. Both of the inequalities are saying that m is greater than something. So you have to ask yourself, which one when I graph it, can take care of both? And the answer is this one. Because if I were to graph just the m is greater than 5, I'd miss out on a whole bunch of numbers. Here's -3, -2, -1, 0, 1, 2, 3, 4, 5. By shading to the right of this greater than or equal to -3, I also get all of the possibilities for 5. If I only would have graphed this one, if I only would have graphed m is greater than 5, I would have missed out on all of these numbers in between here. So that's why this is my solution to this compound inequality. And I hope that gets you off to a good start on solving compound inequalities, and we will